Hello, welcome to my little corner of the universe. My name is Mark Mandel. I'm a developer advocate at Google Cloud. We're going to do some coding and have some fun. We'll see how things go. This should be very entertaining at the very least. How do we want to kick things off today? So today, let's screencast beautiful. Let's do that. Today I want to work on a particularly interesting problem. Within Agones itself. If you're actually interested, this is actually issue 783 on the Agones repository, so if you want to follow along at home. A pretty good description there of everything that's going on, including some of my stream of consciousness and some solutions that I'm thinking about. But why don't we draw some pictures and we can sort of I have this idea of how we might want to like explain this, and then maybe it'll also we might call this packed allocations. Might also have another idea. Maybe this will help me solidify the idea in my head of how I think this should work. I started working on this a bit yesterday, but I ended up realizing that my initial idea wasn't very good. So we're talking about, say, Kubernetes, right? So we'll have multiple nodes. So let's say these boxes. This is a node, this is a node, this is a node. So let's just say we have like 4 nodes for argument's sake. Maybe 1, 2, 3, 4. Okay, that works. That works pretty well. There we go. Let's distribute them that way. Lovely. All right, so we have 4 nodes, and let's say we have game servers on them. So let's just say that's a square is a node, and this is a game server, right? So we might want to give that a different color. Let's make those like dark blue. Cool. All right, so that's a game server. Let's just write a little bit of text next to that. A little text box here. That's a game server. Cool. So that's a game server on each of these. And so let's say we have like, I don't know, 4 or 5 in each node, right? And 1, 2, 3, 4, 5. Cool. Right. And that's 6. So let's just drag you down there. 1, 2, 3, 4, 5. And give me one over here. Okay, so 4, 5. Right, and that's cool, right? And so what we do, that's one extra. I could have dropped it in here. Perfect. All right, so what we do when we do allocation is basically we pull one of these out and we say, hey, this one here, you are now allocated. Awesome. But what we want to do as much as possible is keep allocated stuff as tightly packed together because, all right, so in the cloud, right, we want to keep things tightly packed together because if you think, for example, if I say allocate like this one and this one, right, then these 3 nodes, I can't delete these nodes in this cluster. It makes it very hard for me to scale down, which is not ideal. What we want instead is we want to be like, oh, this is allocated here and this is allocated here, right? Like we want to keep allocating here and then maybe move on to another node, and so on, right? Like so that we could always delete this because there's no players on it, which is cool, all right? That's fine. So that's the ideal. Originally, that's very much how Agones worked, and it did that. When we started doing performance testing, we found that that wasn't the fastest thing in the world. It's very hard to keep this in sync. And so we made some changes to allow much higher throughput, but the packed allocation is a lot less. So if we have a look on this bug here, you can see I took a cluster of 20 nodes, I put up a fleet of 100 game servers, I created 6 allocations or so, and as you can see, these are pretty much all on different nodes, which is less than ideal, very much less than ideal. But it did allow much higher throughput. The way it happens is basically we grab a semi-sorted set and then we randomize over it, and so we don't get contention, right? We don't have multiple requests happening at the same time trying to allocate the game server, which the Kubernetes API is gonna be like, no, you're not gonna let it do it. So we don't get the contention within the Kubernetes API server. Basically, actually, this is an interesting one. So if you try and change a resource inside Kubernetes and somebody else has already changed it, you'll get a conflict. And it'll actually say, hey, like this doesn't match the revision number that you had before. So like you can't change it. Try again with something, either try it again or with a new update or try something completely different. Right? So you get this contention, it slows stuff down. Bad. Don't want that. And to give you an example, if you use the fleet allocation, which still has the old code, it's deprecated right now. But you can see here I did the same thing, and like they're all on exactly the same node. But this uses like a super strong mutex, and so the throughput on this is like ridiculously low, right? So, I mean, we could do, I'm trying to remember the numbers off the top of my head. I mean, game server allocation will push through like 1,000, 10,000 game servers per minute. Like it's a bunch. I think it's like 10,000 per minute. It's like a lot. So the throughput's great. Fleet allocation will do nowhere near that at all. The mutex lock and some other things make this really quite slow. So I have an idea of how we might be able to solve this. Does this let me do like a new sheet or something? So this is my idea. Maybe I can draw this out. So we have this thing called game server allocation, right? Maybe I can bring up an example real quick. Examples. There you go. Game server allocation. This is good to look at, actually. Actually, yeah, this will work really well. I know I think about it. My brain just fell over. Okay, so what do we got? Game server allocation has a couple of fun things. So we're basically trying to grab a bunch of game servers. So we have a required selector, right? So this is basically saying, hey, choose me a group of game servers out of this pool that have this selector on it. Usually you'd probably tie it to a fleet, but you might not. But you're saying like for each allocation, it's an individual allocation that with a given required selector. Now we could also do the thing where we have a preferred selector. So you might allocate out of like a larger group of like, oh, I have maybe five game servers for like a smoke test or something like that. And you might be like, I prefer the smoke test, but I would require everything else from the regular fleet. So if there's room in the smoke test like fleet, like a small one, then sweet, that's awesome. Grab me those. Otherwise, grab me the ones over here. And it's cool. This is actually super nice. This works really well. So what do we want to do? So the idea that I have is that I should actually delete that line because I don't think we're actually going to change it that much. But anyway, that's fine. I digress. The idea that I have is we can cache the sorted results and keep them kind of, what's what I'm looking for, kind of eventually consistently sorted. And then we can atomically pop one off as we need it, which should give us quite high throughput. Because there's no contention, we're always just going to pop one off at the edge. And then also keep it reasonably well sorted over time. So that's my theory. That is my theory. We'll see if it pans out. But that is my theory. So I started doing some work yesterday. And I've got some other details in here. If you want to go look at the actual bug itself, feel free. It's right here. Just check my email. All good. Sweet. I have some other ideas to come along after that. But basically, that's my basic idea. And so I started doing some work on this yesterday, wherein I worked on a little project. Where are we? Not that. Here we go. It was in here, I think it was. Yeah, so I have, not that. I'm on the wrong tag. Where are we? Perf sorted set. Where are we? Perf sorted set. Here we go. Check out. That's better. Okay. So I wrote this thing called a game server sorted set. It's a little, basically it's a wrapper around this nice sorted set container data structure that is a sorted set that has pop and remove. Going sorted set. It's actually super nice. Here we go. It's right here. Go and add an update, get by count, like lots of good things. And I think this works really well. I do need to roll back, I think, some work that I did because I kind of did too much. I went into my controller and I started deleting a bunch of stuff. And now there's a bunch of errors. You can see the red lines here, right? Like this is all not working. So I'm going to roll that back so it's all passing so I can start writing tests again. So let's have a look at my, I have I wrote a plan, so let's see if we can stick to the plan and see what happens. All right. All right. So actually, the first thing I want to do is roll back the things I did to this controller and the code that I deleted. So actually, let's make that bigger. Breaking things and adding things. So I'm just going to git reset soft. We're going to actually kick the last two off. There we go. Things that I've deleted and things that I've modified. Beautiful. I can never remember how to do this. What? I can never remember how to do this. How to unset this. I wonder if this will let me do it from here. Where are we? Right click. Here we go. Git revert. Ah, lovely. Here we go. So I want this is, yeah, IntelliJ is nice. Control yes. Set I do not want to revert. Set stays where it is. Everything else should be fine. So let's do that. Lovely. That's good. Okay, here we have a bunch of stuff. Okay. So I put a really simple API on this. Oh, maybe not simple. So this is my sorted set. I can add or update a game server with an allocated count. So how many allocated game servers are on the node that it's on. I can pop the min value and I can pop the max value. So the least number of ready game servers. So that should be allocated. That'll be handy when I want to distribute the load versus packing the code, but I'm focused on packed right now. Pops the game server with the most number of allocated servers on the node that it is scheduled on. Let's make sure that's right on both. All right, so max is what I want for packed, and then removes the game server. Okay. I do have this cache in here, but I don't want to work it in here, so I'm just going to leave it in set. That's fine. All right. So next step. We keep a cache of sorted, preferred, and required game servers for each game server allocation selector and namespace combo. All right, so that's fun. So what I need is a type. What do you call that? You call that a game server cache entry. Yeah, I'm not doing that. So I have this weird idea. Let's see what we got. So I'm not sure what to call this. In fact, this doesn't need to be public either, because it's only ever going to get used in here. Do refactor. And same thing for all of this. Actually, no, I changed my mind. All right. Anyway, we'll come back to this. Maybe it should be public. Maybe it shouldn't. Let's get it working first. Sorted game server cache, which is a struct. We will probably want a mutex for this, but I'm just trying to think through all the scenarios so that what I need is a map of type string, most likely. Map string game server sorted set, and probably a pointer to that. Cache, I'll just call it that for argument's sake. Yeah, that'll do. Create a constructor for this. Sounds good to me. Oh, no. Generate constructor, select none. Beautiful. Yep. And we can full struct. Oh, that's not very nice. Thank you. All right, so we have a map. Okay, so the theory being, all right, now, so, first part of this. Keep a cache of sorted and preferred required game servers for each. Okay. So what we then need is something like math add or update. I think we need to add or update. Adds or updates the. Let me think about this. Actually, that's no. I have to think about this. This is kind of fun. Well, we need to get cache, so let's start with that. Actually, and I also want to make sure that I can still run tests now as well. Make sure things compile. This is important. All right, things are compiling. Beautiful. All right. Let's work from here. That just gives me a thing to work from. Why is that not working? Why is that not working? Usually my to-dos are... There it is. Weird. Usually it comes up in green. All right, anyway. All right. Roll back and we continue work. All right. Trying to work out how much needs to be in this and how much needs to be in something else. Maybe I'll try and keep this least amount in here. See how that goes. Because what do I need here? All right, let's think this through. If I have it, I need a retriever. I need some kind of retriever to get the thing. So okay, so I need a math. We'll say get. Get seems actually reasonable. Retrieve game server sorted set for a given game server allocation. Nil if it cannot be found. Works for me. Game server sorted set. That's actually not what I wanted. Oh, I'm in the wrong spot. Sorted game server cache. We'll just call it C for cache. Game server. No, what did I call it? Sorted game server cache. Sorted game server cache. Get game server allocation. That looks about right. Return pointer to game server sorted set. I'd like that to be a pointer, please. Let's put that in the right spot in the ordering. Here, that looks better. All right, that doesn't look right. Beautiful. Let's give that a nicer import package. Allocation v1. Okay, let's call that. Let's just call it allocation. I'm okay with that. Allocation v1 alpha 1. Let's do that. Okay. Works for me. Probably want that as a pointer, though I don't think it actually matters. All right. So I'll need a key. I need somehow to get a key from this. So let's write ourselves a little function called cache key pointer allocation v1 alpha game server allocation. Return out a string. Cache key returns the caching key for this game server allocation. It is a combo of namespace and selector string. So key should be allocation dot object meta dot namespace. Right, because we only want a particular namespace. That would be like we don't. Yeah, there could be game servers in different namespaces, and that's important. Ooh. Let me. All right. Anyway, let's. I'm having thoughts, but let's progress forward. Write tests. Key plus equals location. Yeah. Location dot spec dot required. Now, can I toString this? I can. Beautiful. Give me a string. And that does all sorts of fun stuff, which is actually exactly what I want. Plus allocation dot spec dot preferred dot string. What is that? Why is that not? Oh, it's an array of label selectors. That seems weird. What have I done? Required. Ah. That is true. Well, that's just silly, isn't it? All right. Almost wondering whether I want to buffer this. Let's just get it to work though. For underscore value, I don't know, whatever, selector in allocation dot spec, oh sorry, range dot spec dot preferred key plus equals s dot string. Cool. So that gives us a key. I need to write some tests for this, but that gives me a key. So actually, that's a really interesting question. With Golang maps not found, what does that do again? I can't do the OK. I know I can do the OK, but does it return? Here, I'll tell you what. Play.golang. Go to playground. Here we go. V equals map string int foo1. Right? And if we print v foo, we run it, we get 1. And if we put like a s in it that's not anything, does it panic? It returns a 0. That is not what we want. Okay. Map string int pointer to an int. Whoop, what did I do? That can't use type int as an int value. Can I do that? That would be kind of interesting. I equals 1. That will usually work. Nil. Okay, so that does give us nil. All right, sweet. So if we're pointing at a pointer, it will return us. That's basically what I wanted to check. So I should be able to say return c.cache cache key allocation, which is fun. All right, so we can put that in now. What if we look at my thing. Keep a cache of, all right, so we kind of do that. Sorting, okay. When a request comes in for a new key, we build it if it doesn't exist. So this is where I'm struggling with how to do that in a good way. Yeah, like Golang named mutex. Like, can I do a mutex that's got like a manage named rewrite mutexes? Yeah, like something like that. Name mutex is a lock name. No, I don't like that idea either. Turns the existing value. The key if present, otherwise it stores or return the given value. Yeah, that's not what I want either. I'd like to encapsulate this somehow. So basically I'm like, if this doesn't have one, then create one. It's basically my point. Do I solve this here, or do I solve this somewhere else? That is a very good question. Because I wanted to stop and wait. This is really tricky. Maybe I defer that till later. Where we store, delete, load. I hate that term load. Anyway, that's fine. Range. I'd love to have like maybe a get or populate or something with a function that populates it. Trying to think through how I would do this. I'm just gonna commit this real quick. Just because I have a weird idea and I wanna give myself a checkpoint. So if I get or populate, right? Get or populate. Yeah, I don't think it's anywhere. I haven't used it anywhere. Really? No, get or populate. You're not going to break anything. Because my theory is what I would then do is something like func. The interesting question is that fails for some reason. I don't have a good answer. But func that takes a set, game server sorted set, something like that, right? Like, and it would be something like if cache equals nil, cache equals new sorted game server cache. No, new game server sorted set. Populate the cache. C.cache So let's pull the key into its own value. Cache key equals cache. Return cache. Right? Something like that, right? Populates a function so we can specify our own specific population function, which I quite like that idea. Let's just format that nicely. I quite like that idea. So get our populate. So populates it if it's not there. With a thing, populate gauge. Excuse me. Not sure what to do about errors, but that's a whole other thing. Thinking actually maybe something like this probably needs a logger. Let's make a note of that. I'll come back to that later. Do we need a logger? Probably. We're thinking return now, and then we can just continue it from there. Maybe. Maybe. Or maybe it returns an error. Maybe it should return an error. Maybe it should return an error. Yeah, it should return an error. That's better. Bubble that up. No. Beautiful. Though we might want to logger, because that's a whole other thing. Especially in populate, I feel like that's something we should probably do. Awesome. Okay, so that's kind of cool, but there's no what's the word I'm looking for? The problem that I have is basically that I need this to block. And ideally block based on this key. But I want to do a read block if the cache is not nil. Well, actually, let me think about this for a sec. If we hit this point, can I do a... let me think about this. Could we do this with 2 mutexes, maybe? Something like that? I have a weird idea, and I don't know whether it's going to work. So hold on, let me pop over to note that. Play dot Golang. Basically, I'm wondering whether I can do a full lock inside a read write mutex. So mut equals sync dot read write mutex imports. Sweet. Mute dot read write lock. Mute dot read write unlock. Pretty sure it's right. Oh, sorry. Read lock. Let's run. Sweet, and that works fine. Now within here, can I do a full lock? And then a mut dot unlock. Deadlock. I was kind of hoping that would work. Lock here. Lock sorry for writing. For reading or writing, lock blocks until the lock is available. For reading, should be not used for recursing read locking. Excludes new readers from block lock. All right. Returns a locker interface. What is this thing that we are talking about? Is there something I don't want? Yeah, what is that? Returns a locker interface. What is that? With lock and unlock. Fancy. All right. This is where things get tricky. This is where things get tricky. I actually really like the signature on this and like where this is going. I just don't know how to set this up in a way that I want. I was looking at something like something like a conveniently. What I need is a named rewrite locker. Like this. Like literally like this. Session-based information allocations, yeah. Damn, that looks cool. Outbound and long-run programs. Figure out a way of keeping the look. That's a worry. Okay. That's fun. Let's have a look at the code. So it's keeping some sort of global thing in it. All right, so we have a rewrite mutex of locks. And then it has a global mutex for getting the locks so that you can only get locks to the given string at any given point in time. That makes a certain amount of sense. Okay. Lock, get lock. New lock. Yep. Blah, blah, blah. And I do a bunch of stuff. Cool. Something like that could work. Lightweight. Oh, is that the one? Oh, that's just the one I'm looking at right now. There's my dog. Let me stare at this, see if I can work something out. If anyone has thoughts or feelings, basically what I want to do here is lock this section, ideally just for this cache key. Yeah, I agree, Doug. Let's say for argument's sake, I could get a named lock. Let's maybe try that. Let's think in that perspective. I get a named lock. So I could write something like, I get the cache key, I say, see, here's my problem. The cache needs to be in a read lock. But here's it. Ooh, here is an interesting thing. Here is an interesting thing. Yeah, I love you, dog. I actually only need to lock the cache here. And, ooh, maybe this is actually a really good opportunity. Maybe I don't lock. Maybe I just don't. This cache is not going to get updated very often. So maybe I actually use a sync.map. And that's going to solve a lot of my problems. We could potentially double populate a cache. That could happen. But do we care? I don't know if we care. it's going to make our lives easier. So, you know what? Let's do that. I actually really like that idea. So if you're not familiar inside sync, there's this thing called sync.map. Here we go. Map is a Go map interface. Interface that is safe for concurrent use by multiple Go routines without additional locking, etc., etc. Specialized. Most code should use a plain Go map instead with separate locking or coordination for better type safety, blah, blah, blah. It's optimized for two comment when the entry for a given key is only ever written once but read many times, which I expect to be very true for us, as in cases that only grow. Yes. When multiple Go routines read, write, and overwrite entries for disjoint sets of keys. May significantly reduce lock contention. I think this is going to be us. I think at some point we'll need to put something in there that maybe keeps it lower or something, but I think this is a good idea. The other thought I had, I know that, not that LR, there's a, I know, I love you too, dog. my dog loves me. I don't know what she wants. She wants something. Is an LRU cache inside Golang. Oh no, I thought standard package. Isn't there a... Oh, I thought... No, that's not what I want. Yeah, standard packages. I thought there was an LRU cache inside Go. Maybe I'm wrong. I was sure there was. GitHub.com cache. Yeah, LRU. There's something inside Vitess as well. What other particularly in LRU caches, LRU cache recently used. Recent fixture, recent usage, recent occasion. That's terrifying. That's only vaguely terrifying, right? Yeah, that's fine. I'm just gonna use a map. I'm just gonna use a map for now. At some point, we'll probably want to do some kind of LRU type thing here, wherein we can see that like last access for a certain thing, but I'm not going to worry about it now because I just want to see how it works. So yeah, this is my theory. So here we go. Cache should actually be a sync.map. With a sync.map, boop, 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 boop. It'll solve some of my problems. Map. Here we go. Yeah. Okay, that's pretty simple. Sync.map. Boop. There's nothing in it. C.cache. Not range, not store. Load. Key. Now I assume this is or nil if no value present. Results with a. That seems legit. What's wrong with that? Multiple value. Oh, okay. Cache. Okay. If not okay. Populate. Oh. Where are we? What's wrong with that? Oh. This needs to be a pointer to a game server sorted set. Oh, it doesn't like that. Hi, my dog has come for a visit. Isn't that exciting? I don't know what she wants. What's up, baby? What do you want? Who knows? Come here, come inside. What time is it? Alright, cache dot. It's not even. I'm actually going to change the name on that. We're going to call that a set because it's the actual set that we have. God, fun. And then if that works, c.cache.load or store. Store. Ooh, that might be interesting. Do we want to do a load or store? No, because we need to populate step. That's all right. Store key set. Ah, small problem. Call it results. Here set equals result dot pointer game server sort of set. Oops, that's a bit better. Okay, that feels a little better. So we may get double population, but that is okay. So the cache is eventually consistent. Anyway, I think that's okay. I can't think of a better way to do it. I could do a double lock. What is it? What is it? Double if lock or something. Double check locking if. Yeah. Double check locking. I could do a double check locking. That's kind of, ooh, maybe I want to, downside of that, if I do a double check lock, I would have to do a double check name lock. I don't know if it's worth the trouble. Yeah, I don't think it's worth the trouble. Hi. I have a big dog. She's a big silly. Yes, she is. Okay. I don't know what she wants, but she wants something. Let's go imports that. Yeah, I really don't want to start doing named locking, and I think it's just going to get icky. I could double check lock in here. But that would mean that any population that comes through for a new one always goes through this mutex, and that freaks me out. If we had an individual mutex for this cache key, and I don't like that idea either. So I think we'll just deal with having this, unless you want to. We could do stores a value for the key. There is a store or load. Returns the existing value key for present. Otherwise, it stores and gives the return value. Load result is true if the value was loaded. False if it was stored. Why don't we do that? That way, it won't get overwritten. You'll get the original value. You'll get double population, but it won't be written. This will not overwrite the previous entry. We get multiple concurrent populations, which also makes me happy. Okay. I know, I love you. Okay. I think my dog wants to go outside. This seems pretty good. I'm just gonna lint it. See how that goes. And I have some tests. See if it compiles. Oh, even just writing that was kind of painful. How are we doing over here? We might write some tests. Whew. Yep. Sorted game server cache does not have a game server cache is a cache per namespace and selector for sorted results for a game server allocation. Returns a blank sorted game server cache. Okay. That ought to be a bit better. Whew. Yeah, maybe let's write some tests for this and see what we end up with. Cool. Where's my dog? I love this dog. She's decided that she loves me and she's gonna hang out with me. Yes, you are. Yes, you are. Yes, you are. All right. So getting hungry. All right. All right, so it looks pretty good. I'm actually going to commit this. I think this is a possible population strategy. Cool. Do I want to limit this in some way? Dunno, haven't decided. Oh, I love this dog. She's a monster. You may notice I wrote TX like Tuxu rather than to do. Basically, I do this. I have a filter on my to-do list that looks for a TOXO as my to-dos that I've written, so I can like plonk to-dos while I'm working on stuff that aren't going to go in the code base, but give me hints on where I want to work on next, without like having to wade through all the other to-dos that end up showing up in code bases over time. So, alrighty. It's behind it. Yes, that's fine. Overwrite that. Because I rolled a bunch of stuff back. Oh. Let's just roll that into there. All right. Yeah, I may want to limit this to like maybe like, I don't know, 100 or something. Yeah, I'm not entirely sure how we want to do that. Going thread safe LRU or something. Ah. HashiCorp has one. Thread safe LRU cache. Ooh. Now apparently, okay, so all of this is location vector safe locks while operating there for our thread safe consumers. Ah, fancy. Some of these might be particularly nice. Anyway, tracks frequently used and recently used separately. This avoids breadth of accesses, making it frequently used and quotation with some extra bookkeeping. Okay. Or I could just use a simple LRU cache, least recently used. Anyway. Oh, there's a nice unbig. This is actually really quite cute. Contains our add. Oh. Now I'm almost tempted to actually replace it with this. In fact. Now, I'm actually wondering if I have this already in my thing. I had a feeling I did. It's a really nice cache. So maybe I change it. I don't think the it's a cache with, yeah, I think where are we? Get contains or add. Contains or add checks if the key in the cache without interrupting the recent, and if not, adds the value. Returns whether found or whether eviction occurred. Contains if the key in the cache without updating the recentness or deleting it for being stale, and if not, adds the value. Whether this found. All right, contains or add. Why would an eviction occur? Checks if the key in the cache without checks if the key is in the cache without updating the recentness or deleting it for being stale, and if not, if it's not in the cache, then adds it. Okay, actually, yeah, let's switch this out. This will make me happier. After all that, that's exactly what I want. LRU dot new. I'm gonna call it cache. Where are we? Yeah, just int 100. 100 seems like a good value. Why do you not like that? It returns notification an error. Why would you error? Really? New with evict. Cache error returns linear value. Alright, apparently you can throw back an error. That's just hilarious. To T signature result parameters add sorry, type error. Yep. Refactor. Boom. C error. Cannot type pointer cache as LRU cache. Oh, it should be a pointer. That looks better. All right, which it should have been anyway. And error. If error does not even tell, return no error. Because let's turn that into const. Max cache values, something like that. Let's start up here. Nice. Okay, let's fix up the other thing. So here, cache dot get. Let's have a quick look here. Cache and okay. Yep. And then here, contains or add. Sweet. Any values to store in the cache. 100 seems like a good amount. If you're doing 100 different game server allocations, I don't know what you're doing. Either you're doing lots of little ones, which is a whole other problem, and I'm not going to worry about it right now. There you go. All right. is we will take the computational hit, the computational hit, rather than locking this pathway. Double execution here. I like it. Commit switch to LRU cache. Beautiful. Whew. Tricky problems. We haven't even got that far into it yet. Okay. I don't know if I'm 100% in these names. Sorted game server cache. Yeah. It's a really nice little cache, though. I'm quite impressed with how it works. That's fine. Don't care about that. Actually, yeah, it's nice. Contains or add. Yeah, it's quite nice. We have a very similar thing. Contains or add. Something like that. Anyway, let's probably actually get our add. Maybe I don't like populate. I haven't decided, but it's fine for now. That's also what code review is for. Okay. All right, let's write some tests. Let's actually write some tests for this and make me happy. Let's delete that. Yeah, let's do that. Set test. I probably just need a single test for it. So test. That's not quite what I want, but game server sorted set. No. Sorted game server cache. I'm still not sure I like this naming, but we can fix that later. Cache would be new sorted game server cache. Oh, cache error. And assert.no error. T error. Cool. We could actually, yeah, there's nothing, well, there's a few things we'll want to do. Give me a game server. That'll work too. So cache dot get or populate. Oh, I need an allocation. GSA equals game pointer to a game server allocation. Sploot. We will want to rename that. That's not a very good type alias. Rename allocation v1 alpha 1. Oh, my poor dog. I think she needs to go outside. Yeah. Yeah. All right. Give me 10 more minutes. I know. Object meta, colon, object meta. The things I care about, this is actually namespace. We'll call this just default. Actually, we have a default namespace, don't we? Yeah, beautiful. And the selectors are null, so I'm actually just going to leave them as null. That's fine. Actually, we'll see if this fails entirely. That's actually will be a really interesting test to make sure that it doesn't do that. Or that they have default values. They probably will. All right, so get or populate GSA And I know I love you. I love you. Yes. And get our populate, and then there's a function that has this. And if that doesn't work, set dot add or update gs1, and we'll give it a value of 5. Return no. Populated equals true. Sorry, false. Let's also check that. And populated equals true, so that we can now do a few things, which is to say assert.true t populated, and then we can see if we can retrieve it. So set equals cache dot get or populate. Oh, interesting. Do we just need a flat out get? Do we not need a populate? We'll leave it for now. Probably because in application, we're going to call this once. Multiple value. Yeah, get our populates. Returns a set, and it should be underscore error. Assert.noError. Error. Beautiful. Set error. Assert.noError t error. Good stuff. Set dot popmax. GS equals popmax. Assert dot equal t gs1 gs. Oh, my poor dog. I think I need to let her outside. Blew up stuff. Broke something. Ah, interesting. Because it might not be okay. Here we go. So I should actually have a var set, which is a pointer to a game sort or sorted set, and then we can do that. That looks better. So, okay, we put it that way, otherwise we do that. Yeah. Nice. If we, where are we? If we add another GSA, so we say GSA, call this GSA1, GSA1, and then GSA2 equals GSA1 dot do copy, for example, and GSA2 dot required spec.required dot match labels foo equals bar for argument's sake. GSA2, I don't care about that actually. Assert.true t populated. Now, let's do that test again as well. Populated is false. Populated is true cert dot false t populated. Yep, something failed. What failed? Ooh, what failed? Set test 61. Oh, interesting. Nil map. Oh, match labels is a nil map. Perfect. All right, sweet. That looks really good. Awesome. Set cache key, I think, is covered by the test for this, so I'm feeling pretty good about that. All right. First step. Okay, I'm gonna take a short break. I'll be back in about 5 minutes. I'm just gonna let the dog out. So I will be back. I'm just gonna throw that up on screen. You wanna go outside? Yeah, go outside. You go, please. Opa. I am back. It looks like my dog just wanted to sit outside in the sunshine. Of course, she's going to come back in any minute now, which means I'll want to close the back door. But I'll let her sit out there for now. Okay, so we have this getter populate. That feels this feels good. All right. Actually, I should lint this. And I didn't go imports it either. There we go. Let's just see what that shows up with. Okay, so there's a lint issue. Yep, here she comes back. I knew you'd do that. I knew you would do that. I knew it. I knew it. Yep. Ineffectual assignment to error. There we go. So that's another thing we'll need to fix. All right. Let me close the back door. I'll be back. Why are you so silly? Why? Okay, back at it. Suki has come to help. All right. Set test line 64. Let's have a look-see. All right. Oh, yep. Cert dot no error. All right, let's run that now. It should be fine. Perfect. Let's load that up with that. All right. I don't think I left around any 2XOs. Nope. Beautiful. So no to-dos either. Fantastic. What else? What was on my next list? Oh, I can actually merge some PRs while I'm sitting here as well. Beautiful. Squash and merge. Might as well keep these up to date and get the queue kicking through. There's this big dog sitting right here. Alright, so that's going on. Alright, so once a new one, we build a cache if it doesn't exist. Alright, sweet. On allocation, we grab the cache for that key and atomically pop off. If it fails due to conflict, game server is deleted, remove it from all caches. Game server is deleted, remove it from all caches. So I need a way to range over my caches so that I can remove stuff. And I need to update the sorting of all game servers. This one's an interesting one in that I can't go. It's an interesting question. With the LRU cache, where are you? Set cache, LRU cache. New, whatever, blah, blah, add key. Key is an interface. Ooh, interesting. Let's say, for argument's sake, I did something slightly different. No, my thinking is if I need to come back around and get all the game servers and match them up to things, and basically say like, hey, you need to update your count. What I will need to do is basically to say, okay, here is my sorted cache. I'd rather not do that many contains operations. That seems wasteful. I mean, I could. Right, but I don't want to be looking and yeah. I mean, I could do a bunch of contains. I was actually, yeah, so the, fun. What I was thinking is I could store the spec with as the key rather than use the cache key. That means I do need to have a list of namespaces, basically. If I change this, for argument's sake, let's see what happens. Key equals not cache key. Key equals not set, but allocation dot spec. Run the test now. Interesting. Hash on hashable type. Ooh, what does that mean? That's a new one. How to tell if a value is hashable. Here's my dog. I love her so much. Tell if a value is hashable. Check whether the interface value is stored. Yeah, one of these go functions for closure for type hash equals. Yeah, that'd be nice. Woo. Can I specify a hash function? Going. Just standard library, implement the encoding bounds. Oh, interesting. No, that doesn't seem like what I want. That doesn't tell me what I really need to know. Trying to implement a toy search struct. First up, a simple set. Could we use VW set boolean? It's a key. I'm going to construct to your struct. Key. If you want to be able to compare equivalent structs, you can output a key for struct into string. Okay, that's basically what I need. Okay, all right. All right. You know what I could do? Inside my game server sorted set, I could actually also store the selector. Maybe, maybe not. Let's come back to that. Let's come back to it. Let's just come back to it. I think there's a couple of different potential solutions here, and there are a few different ideas of what we can do for what we need. All right. Yeah, for this is going to be the fun bit, but that's fine. If a game server is deleted, remove it from all caches. All right, so it's kind of the same problem, but let's think about this. Yeah, so it actually ends up being the same problem. So a naive implementation of this could be something like math removes this game server from all caches. Ooh, and I've also realized something else too. Yeah, I'm gonna need an in-memory data thing, cause populate's actually wrong. Yeah, yep. All right. Just realized it's wrong. I'll tell you why it's wrong. It is wrong because I need both a preferred and a required sorted set, so I can search one before the other. So I actually need multiple of them. And so what I need then is a type, is it like an entry, maybe? Sorted cache entry, I think is accurate. So we'll have a selector, which is a, what's the word I'm looking for? actually will be a allocation spec. Game server pointer to a game server allocation spec. I think that's the best option. I have both required and preferred. Required selector. Yeah, that's better. What is that? That's a required is a label selector. Meta v1 label selector. Give that a .imp, which will be oops, that's not what I want. A merge declaration up. Interesting. Add .import alias. No, I want to rename it. Oh. Meta v1. Is that label selector? Is that a is a struct? Interesting, it's not a pointer. Anyway, it's fine. I was looking at this before. Games for allocation, required selector, preferred selector. Actually, why don't I just grab that because it's easier. Required, preferred. Oh, these are selectors. Selectors. Required game servers, which will be a pointer to game server sorted sets, and then preferred game servers. Oh my god, that's hilarious. Okay, populate will now take a preferred and a required. Because I'm just going to break everything. Sorted cache entry is an entry for the cache. Oh my god. This is fun. All right, so the LRU cache, beautiful, blah, blah, blah. All right, get or populates allocation. Yep. Function preferred game sorted set, required game sorted set. I probably need a selector. Oh no, I can get the selectors from here. I'm good. Key equals cache key. Result is the cache. Nope. Sorted cache entry. No. Fill struct. Perfect. Required selector. Why are you complaining? No. That's why you're complaining. Required selector would be allocation. Nope. It can be allocation.spec.required. Allocation.spec.preferred. New game server sorted set. And a new game server sorted set. Oh my god. This idea better freaking work by the time I get to it, because this has been tricky as hell. To get this into a space that I'm happy with it. And I'm not even touching, I haven't even got to the code where it gets populated actually. This is just working through all the use cases. All right, set, actually that not becomes that, but that becomes rename to entry. Yeah, exactly. Populate entry dot, what's the order? Preferred and entry dot required. Whew. Entry is entry, sorted cache entry. Cannot use sorted cache entry. Oh, what do I spit back out? I think. Yeah, I might as well spit back out a sorted cache entry. Like that's kind of the point. I'll have some extra stuff on there, but I think that's fine. In which case, should I just pass through the entry entirely? Rather than two individual ones? No, I think that's a bit cleaner. Yeah. Yeah, I think it's fine. Fun. Alright, so my tests are now broken. I think this is t.run test population. Test population and retrieval. Whew. Oh yeah, I'm getting tired. I have a meeting at some point today. Let's have a look. In 12 minutes. All right. All right. This becomes one. Yeah. Third. Give me two of these. Acquired. Add or update GS2 4. That should be fine. Just drop that in there. That looks pretty good. All right, so same test, beautiful. That's not set. That'll be entry. Entry dot preferred. Game service pop max. Entry dot acquired. Should be just 2. Create a new one. Same thing. Here we go. Goes there. Just make sure that. All right. So go imports. Let's run that. Passes. Lovely. Oh my, lots of fun. See if that lint's okay. That lint's okay. I think we might call it a day at that point. Beautiful. Refactor to using an entry. Alrighty. I think we're going to call it a day there. Whew. That was fun. Still not done. I may come back this afternoon. We'll see how we go. That gets us part of the way there. So now that we have an entry, we can actually loop. If we have a group of list, basically the theory is if we have a list of game servers, we can loop around each of the caches within the sorted the game server cache, right? Loop through them, check to see if either of the selectors match that game server, and if so, I can go remove it. If not, otherwise I don't have to hit those locks. The actual not sorted set, this one here. Let me look at the, here we go, doc. So I wanted to see, here we go. Contains, get, key, peak, purge, beautiful. Okay, I didn't know if it had a range, which is totally fine. Keys, I can get a list of keys. That all sounds fine. Yeah, so that's all good. Yeah, the lovely thing about this plan that I actually really like is we can go and delete stuff if we find there's reason to delete stuff. But even if we didn't delete stuff, eventually it's going to get popped off the thing. And it's going to get popped off the thing, and it'll be like, oh, I errored out because I don't exist or I'm not found or something like that. And we're just going to go, cool, don't care, and just get rid of it. And not add it back on. So, which is actually really cool. So it's super nice. And then it'll eventually go away. Like we'll get a little bit of contention or a little error, and then we'll just try again, and that's fine. So this should be quite self-cleaning, which actually makes me super happy. Awesome. I think I'm going to quit it about there. I'm going to try and get back to streaming on Tuesdays on a regular basis, maybe around 9 a.m. We'll see how we go. It depends on my day. But if you want to find out when I will be streaming next, please subscribe to me at Neurotic on Twitter. I usually chuck something on there, or obviously subscribe here on Twitch. I will put the recordings up on YouTube as well, as I do always. So if you're watching on YouTube, come find me on Twitch. If you're watching me on Twitch, come find me on YouTube. Otherwise, thank you so much for hanging out with me. I hope that was at least somewhat useful and somewhat interesting as I potted around in some interesting and weird ideas. So I appreciate you taking the time. Awesome. Well, if I don't see you all later this week, have a good week, and I will catch you all later.